Alright, here, so C here is asking us to verify that theta is equal to pi over 6 is a solution for the equation. So here, once again, we're just going to substitute into the equation. So we have cosecant of pi over 6 is equal to the cotan of pi over 6, divide that by cosine of pi over 6. Okay. Here I want to change all of this to our primary trig function, so that is, I'm going to rewrite this as 1 over sine of pi over 6. That is equal to 1 over tan of pi over 6. Divide that by cosine of pi over 6. There we are. So now I can fill in our values there. So I know that sine of pi over 6 is equal to 1/2. So that is going to be 1 divided by 1/2. And tan of pi over 6, that is equal to 1 over root 3. And cosine at pi over 6 is root 3 over 2. Okay. Now let's simplify all these lovely fractions here. So your 1 divided by 1/2, using your fractions there, you get 2 is equal to, here we have, flip your fractions there, so we have root 3 over 1. Times that by flipping this fraction there once again. Yikes, that's a lot of craziness in one step. That's going to be 2 divided by root 3. So that's just using your fraction rules here. So this one gets simplified to 1 times that by root 3 over 1. Then you get root 3 over 1. And because we're dividing by a fraction again, here we got to flip this one. So here we have 2 divided by root 3. Here our root 3's cancel out, and 2 is equal to 2. And that is absolutely true. So here we can say that when theta is pi over 6, our equations here are true. So that's cool. Okay, so D says to use technology to graphically determine whether this equation could be an identity over the domain negative 360 to 360 degrees. So here you're going to pull out your calculator. I'm going to quickly pull out my Desmos online. Right, so here you're going to graph each of them, each side of the equation separately. So we're going to put cosecant of theta, or of x, for this one. And then here I'll do cotan of x, divide that by cosine of x. Alright, so I'm just going to move our window on over more towards our graph. So here I can flip back and forth between the two, and you should notice a slight color change there. So just by graphing them, they look like they would be, or like they look like they could be possible identities, but we'd actually need to prove this first. So to answer number D, I'm just going to go back to our Word document. So here we can say that for D, by graphing, y is equal to cosecant of x, and y is equal to cotan of x divided by cosine of x. The graphs appear to look identical. So they could, that's the key word there, they could be an identity. Okay, so remember, this is not proving it, so they said, so we could say that they could be this could be an identity. Alright. Alright, so now let's move on down to B. Alright, and this one here, I'm not sure why this one's B, but it should be 2. I'll change this one here 2, then we'll go to 3 and 4 and so on. Alright, so in this question here, we have to determine the non-permissible values in radians of the variable in the expression tan of x times cosine of x, and that's all divided by secant of x multiplied by cotan of x. And we also need to simplify the expression and write this in terms of cosine or sine, which we will see happen when we simplify the expression. Alright, so for our first one here, we need to define the non-permissible values. So we're going to examine each individual little trig function that we have there and see if there's any non-permissible values there. So for the top one, typically if it was sine or cosine, those ones will never give you non-permissible values in the numerator, but here we have tan of x, which is a quotient identity. So tan of x, we can rewrite as sine of x, divide that by cosine of x, and what we want to look here at is cosine of x, because this one can give us a 0 in the denominator. So we want to know when cosine of x is equal to 0. looking at your unit circle, if you guys know that, hopefully by now we're starting to get really familiar with our unit circle. And here we can say that x cannot equal, we're dealing with here in radians, so it'll be pi over 2, 3 pi over 2, and so on. It didn't give us any restrictions here, so we should really make a generalized, I guess, written expression of what x cannot be. So x cannot be pi over 2 plus pi n, where n cannot equal integers. So hopefully this whole generalization thing should be pretty easy by now. Hopefully, we've done this a lot, so should be good. Okay, so tan of x is good. We don't need to worry about cosine up here. Down there is a fraction, or it never gives us a fraction, so it should be fine. So next one here, we need to look at the secant of x. Your secant of x is equal to 1 over cosine of x. And once again, we don't need to look at this because we already did that over here. So that one is absolutely fine. It follows the same rules, so we don't have to worry about that. So for our next one, our last one here, we have to worry about cotan of x. That one can be written as, oh, and that's going to be cosine of x. Divide that by sine of x. Draw little lines here to help separate that for you guys. Alright, so here we're going to look at cotan of x, and that is cosine of x divided by sine of x. So we don't need to worry about cosine there, but we do need to worry about sine because that one is in the denominator, so can run into some problems there. Alright, so here we want to know when will sine of x equal 0? And using your unit circle again, you guys will see that sine of x is at 0, pi, 2 pi, and so on. And once again, we do not have any restrictions, so let's make a generalized form. So we can say that x cannot equal, we could say pi plus pi n, where n is an element of integers. Then we can put this all together, combine these two here because there's a nice little pattern there where we can, or I guess, yeah, there's a little in-between values there, so we could say that all of our non-permissible values there cannot be pi over 2 plus pi over 2n, where n is an element of integers. So that's just saying here we go from 0 to pi over 2 to pi, so it's jumping up every pi over 2. So we could start with pi over 2 plus any multiple of pi over 2. Alright. Got a nice little squiggly line here. Hopefully you guys don't have monster writing like me, and you should have hopefully a whole bunch more room than what I'm showing here on the screen. Yikes. Alright. So here B, we need to simplify the expression. So this one here, we're going to be looking at our identities that we looked at the beginning of this section here. So let's rewrite this, and it wants it in terms of cosine and sine. So basically what we're going to be looking at here is we're going to be changing at some point to either tan of x, secant of x, and cotan of x. Alright. So to start, let's get rid of, we'll do tan of x. So tan of x can be written as sine of x divided up by cosine of x. This is multiplying with cosine there. And this is all divided by secant of x, which if you write that into, flip that over, that is cosine of x times that by cotan, which is cosine of x, divide that by sine. Alright, so from here, let's just cancel out anything that we can. So there's 2 cosine in the numerator and the denominator, and here as well. What we're going to find, what we're left with here is sine x, divide that by, remember there's still that 1 there in the numerator, and your sine of x here still in the denominator, so we have sine of x, divide that by 1 over sine x. Using your fraction rules, we're going to flip this. So you have sine of x times sine of x. If you guys want to write divided by 1, we don't need to. And that can simply be just sine squared x. Alright. So literally you're just using all those identities that I gave you, just manipulate them and then just simplify and solve. So it's pretty easy that way, hopefully. Okay, so let's move on to question 2a, or well, really should be 3a. Okay, and I'll just draw a little, oops, wow, okay, that's great. Let's just draw a little line here to help separate that. Okay, so for 3a, we need to verify that the equation cotan squared x minus cosecant squared x is equal to -1. And we need to verify that it's true for x is equal to pi over 4. So here we're just going to substitute values in. So here we have that cotan squared of pi over 4 minus cosecant squared of pi over 4, and that should be equal to -1. So to start off, I'm going to change these into our nice primary trig functions. So we have 1 divided by tan of pi over 4, subtracted by 1 over, oh, I'm sorry, this should be squared. 1, and then we have subtract 1 over sine squared of pi over 4, and that should be equal to -1. And sorry, these squared looks like they're with the pi, but this is squared values right there. Okay. So from there, you guys can, if you guys want to, you can write this as tan pi over 4 times tan pi over 4. That's the exact same thing as this, what the squared value here does. So what we can say, tan of pi over 4, that is equal to 1 squared. Subtract 1 over sine squared pi over 4, so find that sine of pi over 4 value. That is 1 over root 2. That'll be squared is equal to -1. Okay, so from here we have 1, subtract 1 over, that'll be just 2, because root 2 times root 2 will just be 2. That is equal to -1. Alright, and I'm just going to move this on over here, ladies. So going from here, we have 1 minus, and using your fraction and division rules or properties, we get 1 minus 2 is equal to -1, and 1 minus 2 is in fact -1. Cool, so that works. Alright, so moving on to B, our last one. We can do this. We've got like 3 minutes. I'm going to blast through this really efficiently. Okay, so here we need to use quotient identities to express the first Pythagorean identity that we were given, and we need to rewrite this as cotan squared of x minus cosecant squared of x is equal to -1. So basically we're going to show that they're basically equivalent. So number 1 is equivalent to, I believe that was number 3. Oh no, that's the second one. Okay, number 1 is equivalent to number 2. Okay, so here we're going to start off with cosine squared of x plus sine squared of x is equal to 1. So as I was saying, divide everything here by sine squared of x. Alright. And then we just simplify from here. We know that cos divided by sine, that is equal to cotan. And because they're squared here, they're going to have the squared values there. So we have cotan squared of x plus sine squared of x divided by sine squared of x. That reduces to just 1. And that is equal to 1 divided by sine squared of x. Using that reciprocal, we know that sine is equal to 1 divided by sine squared of x is equal to cosecant squared of x. Alright. And then just manipulate this equation here. So we're going to subtract 1 on each side. So we're going to move that on over, and as well subtract cosecant squared of x. And what we'll find that here, so we have cotan squared x minus cosecant squared x is equal to, here we're going to subtract -1, or subtract 1 from each side, and here we have our identity if I didn't just cross or draw through it. But this is essentially right up here. That is exactly what we had, and if you scroll up, if you guys don't mind, I'm just going to scroll up here. That is our second identity right here as I draw through it again. Awesome. So if you guys had to do, say for the third one here, just do exactly as this one here says. So instead of dividing by sine squared of theta, it is cosine squared of theta. Alright, so hopefully that is alright for you ladies, so you guys can get started on your homework, and feel free to definitely ask me some questions. I'll make sure to come on and check on you guys. Alright, it's a kind of a hefty one, so it's okay if we're having a little bit of a hard time, especially with manipulating. Eventually, it really doesn't matter which way you go, especially when you're, say, simplifying a really complicated expression. It just might take some time getting there. Sometimes you don't know, well, when do I use this, when do I use that? It just comes with experience. So do the homework, and it will definitely help you guys out with, and you'll get your brain thinking about when you need to use a certain identity, okay? So have fun, ladies. Oh, and let me know how my stylus writing thing works. I kind of enjoy it so far, so hopefully you do too.